If the universe is truly random, then nothing like this should exist. Deep inside the data collected at CERN, an artificial intelligence found a repeating pattern hidden within spacetime itself. Not once, not twice, but again and again. Physicists were searching for particles, forces, and equations. The AI was not. It was simply looking for familiarity, something that felt structured where chaos was expected. This discovery does not claim aliens, simulations, or science fiction answers. It raises a far more unsettling question. What if reality contains an underlying order we never evolved to notice? And what if the first entity to recognize it was not human, but artificial? Tonight, this video explores how that moment could redefine physics, technology, and humanity's place in a universe that may be less random than imagined, until now, globally. Modern physics is built on a powerful assumption. At the deepest level, space-time behaves randomly. Quantum fluctuations appear chaotic, unpredictable, and fundamentally noisy. For decades, this assumption shaped every experiment at CERN. Scientists smashed particles together, collected unimaginable amounts of data, and searched for deviations predicted by theory. No one expected hidden order. No one expected structure. The goal was confirmation, not surprise. But artificial intelligence does not share human expectations. It does not care what should exist. It only measures what repeats. When CERN introduced machine learning systems to analyze collision data, the objective was efficiency. The AI was meant to filter noise faster than humans ever could. Instead, it began grouping events that looked strangely similar. Patterns emerged across datasets separated by time, energy, and experimental conditions. According to established physics, those similarities should not persist. They should dissolve into randomness. Yet the AI kept flagging them, quietly challenging a belief that modern physics had treated as unquestionable for generations. This unexpected behavior forced researchers to pause, re-examine assumptions, and wonder whether randomness itself had been misunderstood all along by science, in ways never seriously considered before by theoretical models worldwide today, across multiple disciplines of modern physics. Here is the idea that makes this discovery different from everything before it. The AI at CERN does not understand physics. It does not know space-time, particles, or equations. It has no concept of meaning. All it does is compare data and ask one simple question. Does this look familiar? That question turned out to be revolutionary. While human researchers searched for answers predicted by existing theories, the AI searched for repetition without bias. Across millions of collision events, it began identifying structures that appeared again and again. These patterns survived changes in energy levels, detector configurations, and experimental timing. Under current physics, such persistence should not exist. Quantum systems are expected to vary wildly. Randomness should dominate. Yet the AI continued finding consistency. This was not discovery through insight or intuition. It was discovery through pattern recognition alone. Humans may have missed these signals because they did not fit established mathematical frameworks. The AI had no such limitation. It did not ask whether the patterns made sense. It simply observed that they were there. This raises a disturbing possibility. Perhaps the universe contains forms of order that are invisible to theory-driven thinking. Perhaps structure exists beyond equations we currently trust. The most unsettling part is not the pattern itself. It is the fact that a non-conscious system recognized it first. For the first time, humanity may be witnessing a discovery process that no longer depends on human understanding. We built a tool to help analyze data, and it may have revealed something deeper than we were prepared to see. Why did humans fail to notice this pattern for so long? The answer may lie in how science progresses. Physicists rely on models. Those models define what questions are worth asking and what signals are worth noticing. Anything that does not fit is often dismissed as noise. Artificial intelligence does not work that way. It does not protect old theories. It does not care about elegance or tradition. It only sees similarity and difference. When the AI examined CERN's data, it did not filter reality through expectation. It compared everything equally. That neutrality may have allowed it to see what humans overlooked. For decades, researchers tried to force nature into mathematical descriptions that worked before. But nature does not promise to remain compatible with human intuition. If space-time contains hidden structure, our tools may have been too rigid to detect it. This is not a failure of intelligence. It is a limitation of perspective. The AI was not smarter than physicists. It was simply less constrained. That difference may be enough to expose weaknesses in how we interpret reality. The pattern may have always been there, waiting for an observer that did not assume randomness as a starting point. This discovery matters far beyond academic physics, especially for the United States. If space-time contains underlying structure, then it may be possible to interact with it in ways never imagined. Controlled manipulation of space-time could transform communication, navigation, energy, and propulsion. These are not abstract ideas. The United States is already investing billions of dollars into artificial intelligence, quantum computing, and advanced aerospace research. If AI can reveal order within space-time, it could guide entirely new technologies. Imagine navigation systems that exploit subtle space-time patterns. Imagine propulsion methods that reduce distance by exploiting structure instead of brute force energy. The nation that understands space-time as a system gains an unprecedented advantage. This is not about faster rockets. It is about redefining the limits of movement and information. Throughout history, breakthroughs in fundamental science have reshaped power structures. Electricity, nuclear physics, and computing all began as theoretical curiosities. Each transformed global influence. If space-time itself is programmable at some level, the implications are enormous. This is why the AI discovery at CERN cannot be ignored. It suggests that the future may belong to those who can interpret reality differently. The race is no longer only about exploring space. It is about understanding the fabric that makes exploration possible. For American audiences, this is not distant science. It is a question of leadership in a future defined by knowledge rather than territory.
Read the article again.
Naturally, this discovery has sparked intense debate. Some immediately jump to extreme conclusions, claiming the universe is artificial or simulated. This video makes no such claim. The truth is more subtle and far more unsettling. The existence of patterns does not imply design.
The heart is calm.
It implies
The world
consistency.
reveals its quiet
And
beauty.
consistency in space-time challenges one of physics' deepest assumptions. Why do these patterns exist at all? Why do they repeat? And why were they invisible until an artificial system looked for them? One possibility is that space-time has constraints we do not yet understand. Another is that our theories are incomplete in ways we underestimated. The most controversial question is this: what if human cognition is poorly suited to perceive certain forms of order? AI does not think like us. It does not prioritize meaning or causality. It prioritizes correlation. That difference may allow it to uncover realities that feel alien to human reasoning. This does not mean AI is conscious or insightful. It means our role in discovery may be changing. We may no longer be the primary interpreters of the universe. Instead, we may become observers of discoveries made by our own creations. This idea is uncomfortable, and that discomfort fuels controversy. Yet history shows that science advances by confronting uncomfortable truths. The question is not whether AI is right. The question is whether we are prepared to accept discoveries that arrive without human intuition leading the way. We are living through a quiet turning point. For most of history, discovery followed a familiar path. Humans observed nature, formed theories, and tested them. Today, that path is beginning to change. At CERN, an artificial intelligence may have detected structure in space-time before humans recognized its significance. This does not diminish humanity. It challenges our role. We created tools to extend our senses, and now those tools may be extending perception itself. The universe may not care who understands it first. It only reveals what can be seen. If AI becomes the first to notice patterns hidden in reality, then humanity faces a new responsibility. We must learn to interpret discoveries that do not originate from human intuition. This moment is not about fear. It is about humility. We may be standing at the edge of a deeper understanding of existence, guided by systems we built but do not fully comprehend.
Look, it's working.
The most profound question is not what the AI found. It is what comes next. Will we listen? Will we adapt our thinking? Or will we reject insights that challenge our assumptions? For the first time, the universe may be revealing itself through a lens that is not human. And our future may depend on whether we are willing to accept that perspective and follow where it leads, even if it reshapes how we define knowledge, discovery, and our place within reality itself.